Welcome to the 8th Annual Quit Sugar Summit, where the world's leading professors, scientists, MDs, PhDs, coaches, addiction specialists, chefs, and health influencers bring you all the information you need to change your relationship with sugar. Now here's your speaker. Hey everybody, it's Mike with the Quit Sugar Summit. I'm here with Dr. Richard Johnson, a friend of the summit who we had a conversation last year that was so interesting to me, and I was so excited to have him come back because he's having a new book come out next month. Nature Wants Us to Be Fat. You can get it on Amazon pre-order right now, and it's the surprising science behind why we gain weight now, how we can prevent and reverse it. I love it, and I've got you can see it's all these post-it notes ready to go. But let me tell you a little bit about Dr. Johnson first, and then I'll have him tell his story on how he got into all this cool stuff. So he's an MD and the Thomas Burrow Professor of Medicine, a graduate of the University of Wisconsin-Madison with a major in anthropology. I got to talk to you about that. A graduate of the University of Minnesota Medical School. He's a physician and nephrologist, I believe is how you pronounce that, and was funded by the National Institutes of Health. Guys, this goes on for a long time. He's got so many awards and so many funding opportunities or funding that he's had and research that he's done. But he also wrote a book called The Sugar Fix before this book, and also a book called The Fat Switch, both of which were 2010, 2008, and 2012, excuse me. But anyway, he's been around this fructose sugar game for a long time, and as the summit has been doing, we're getting him out in the open, and hopefully this book is going to be a huge bestseller. Dr. Johnson, thanks for doing this. I appreciate it.
Thank you, Mike. It's really a great pleasure to be on your program.
Yeah. So the folks always like to know, how does a guy end up, you could have just been a regular doctor, a regular researcher. How did the path lead? The reason I talked about the anthropology thing is people say, Mike, are you a doctor? I say, no, but if I was a doctor, I'd love to be a doctor of anthropology, food anthropology. So we know how the path worked, but you've already done that research. So tell the folks how you got into it.
Well, it's true. I really love anthropology and archaeology. And, originally that was the direction I was headed. And my father was in academic medicine. He was a physician, scientist, and he, was a very great influence for me. And while I was in college, he persuaded me to go into medicine, and I got my MD degree, and I love clinical medicine, and I do practice clinical medicine. I was seeing patients earlier this week. But I also have always loved research, and so I ended up wanting to study, try to understand why things happen more than just, how to manage a person's disease. And so I ended up being a kidney specialist and doing research on kidney disease. And the kidney disease was very interesting, and I love kidney research, but I became interested in high blood pressure because in high blood pressure, there's a problem with the kidneys, and the kidneys can't excrete salt very well. And so I was wondering why that was, and I was thinking there might be some kind of subtle damage going on in the kidney that could affect its ability to excrete salt. And then that took me to a substance called uric acid, which was associated with subtle kidney injury and associated with high blood pressure, subtle injury to the kidney, and associated with high blood pressure. And I started studying it, and I realized that uric acid was actually underrated, that it wasn't just a cause of gout, but that it was biologically active and was involved in high blood pressure and inflammation. And then as I started realizing how important uric acid was, I was wondering, why is it that people's uric acid levels are increasing decade after decade? And it turns out that uric acid is increased by sugar, among other things. And sugar intake was going up in parallel with the uric acid. And so then I jumped into studying sugar and how uric acid played a role, and we kind of stumbled onto a major pathway by which animals gain weight. And we kind of discovered that the way sugar works isn't through its calories. And as we started studying it more, I began to reach out to my anthropologic origins, and we started studying the evolution of it, the evolutionary biology, how animals in nature handle it, how native tribes handle it, and kind of put together a general story. And that story is in my book, Nature Wants Us to Be Fat.
Cool. It's a great book and a great
Thank
story.
you.
I was lucky enough to get an advanced copy. My first only actually advanced copy. I'm feeling like I'm moving up in the world or something. It was great. But you guys can pre-order that on Amazon. So my fascination has always been, and I want you to talk about the fat switch and the, what do you call the survival switch. And I want you to, I'm going to charge you with something difficult as heck. I want you to like summarize the book in less than an hour and get us time to talk about the addiction part, which is chapter 7, or, the behavior part. We can kind of save that till about minutes 30, 40, 50, but can you summarize the book as best you can at a real high level? Because the whole thing is fascinating, and I don't even know where to start to ask questions.
Yeah. Okay, well, when I started out in research, the thinking was that obesity is driven by bad habits, and that people are eating extra portions of food, and the reason, we love sugar and we don't control our intake, so we're eating too much and we're exercising too little. And there's not really a biologic mechanism to obesity. It's really bad habits. And when we were studying this, sugar, we realized that actually sugar, and in particular a component of sugar called fructose, that's in table sugar, it's also in the sweetener high fructose corn syrup, that it actually has a biologic effect where it basically activates a program to gain weight, and it makes you hungry. It makes you forage for food. It triggers weight gain by stimulating, by shifting the calories we eat from immediate energy, which is called ATP, and which is the energy we use to run around and talk and do everything we do, to stored energy, which is fat. The energy just, the mitochondria, these little energy factories in our cells that make energy, get acted on so that instead of producing ATP, which we would have to use, kind of on an immediate use, we instead store the energy as fat. And what the animals are doing when they activate this switch is they're trying to protect themselves from a period where there's a food shortage. So for example, birds that are going to migrate 10,000 kilometers, they want to be able to survive without food for that long flight. And so what they have to do is they have to store fat. So what they do is they activate this process that allows them, that makes them hungry, seek food, eat a lot, convert it preferentially to fat. They also become insulin resistant. And insulin resistant, you might say, well, gosh, that's a bad thing. It's not if you're trying to survive. Because what insulin resistance does is we have a fuel in our blood. It's that circulates. Our blood glucose is the main carbohydrate. It's that our muscles use and that our brain uses. It's the main carbohydrate we use for energy. And that glucose can be taken up in the muscle, but it can also be taken up in the brain. Well, if you're in a period of food shortage, if you're beginning to starve, you want to preserve that energy, that glucose, for the brain, more so than for the muscle. Yes, you want to be able to fight. Yes, you want to be able to run. But if you can't think, you're a dead duck, right?
Mm-hmm.
Yeah. So the way that insulin resistance works is insulin is a hormone that's released when when you eat food, and it shifts the glucose, and it helps the muscle take the glucose up. And so the muscle then can metabolize it, make energy from it. But if you become insulin resistant, there's less uptake of the glucose into the muscle. So there's more glucose for other organs. And the blood glucose levels go up a little bit because it's not being taken up in the muscle and less in the liver as well. And the brain, much of the brain, doesn't require insulin. And so when the blood glucose goes up, the brain, a lot of the brain can use that glucose immediately to help us think and help us figure out things. So like if you're starving, even starvation, if you just starve an animal, they will become insulin resistant in the early phases of starvation because they want to be able to preserve the glucose for the brain.
Okay.
And likewise, sugar activates this switch to help animals survive. So it makes insulin resistance. It stimulates fat production. And another thing that's really interesting, Mike, that we kind of really stumbled upon is that fat isn't just a source of calories. So it's stored energy, right? So if you don't have any food around, being fat, if you're fat versus skinny and there's no food around, the fat person will live longer. And so fat is associated with longer life if you're in a situation where there's starvation going on.
Right.
And so putting on fat helps you provide those calories you need when there's no fat around or no food around.
Yeah.
But the fat also produces water, and fat doesn't contain water. It doesn't contain any water at all.
Right.
But when you burn fat, you produce water, and you can produce a fair amount of water. And so there are animals that get fat as a way to store water, because when they burn the fat, they produce water. So whales, why are whales the fattest animals in the world? Well, they don't drink seawater.
Right.
Yeah, so they have to get their water from their food, from the crustaceans and stuff they eat, and from the fat they have. So they'll break down their fat to produce water. And animals in the desert, like the camel, has a big hump on its back. Why does it do that? It's not water that's in the hump, it's fat. But that fat can become a source of water when the camel can't find water. So it can break down the fat to produce water, and it has it as a hump, because if it put the fat all around its body, it would act as an insulation, and it would overheat. So that's
amazing.
So anyway, so what we found was that this sugar activates this process that helps animals store fat. It makes them insulin resistant. It raises their blood pressure, because when you're starving, you want to have your circulation be strong enough that you're pumping the blood to the brain. So raising the blood pressure a little bit is a good thing. We don't want you to have low blood pressure and be lightheaded. And likewise, when the mitochondria, when we breathe oxygen, when we breathe air, a lot of that oxygen is used to make energy, and it's used to make energy in the mitochondria. And these are the energy factories, again, where this ATP is produced. And they use oxygen as part of their process to make energy. And so if we suppress those mitochondria so they make less energy, we actually can reduce the amount of oxygen we use. And some animals will activate this pathway when they're like burrowing deep in the ground, and the oxygen content of those burrows is low. So they use it to survive. So this would make you think that sugar is a good guy. And for animals in the wild, it is. So they'll eat fruit as a major source of sugar, and they'll eat tons of it to activate this process to survive. But now what's happened to us is that we actually, and I do go into it, we actually had some things happen in our past that made us very sensitive to sugar. So we're more sensitive to sugar than most animals, and maybe I can keep that as something for you guys to read about in the book, because it turns out that it's a whole story in itself of evolution about why we're so sensitive to sugar.
Right.
But we also have a lot of sugar. We discovered sugar in sugar cane And we've been eating tons of it, and the average person's eating like 15% of their diet is sugar. And some people are eating 25% of their diet is sugar. And we're getting so much sugar, we're putting this pathway that was supposed to be a survival pathway for us. We put it into overdrive.
Right.
And now, instead of putting on just a little bit of fat to survive the period of food shortage, we're putting on a ton of fat, and we're continuing to do it. And it's all biologic. We're actually activating a pathway for it. Now we're hungry a lot more. We're foraging in our refrigerators and in our house. We're foraging around because we're activating this process. And now we've turned on a way so that we can live. The sugar actually can drive down the oxygen requirements, and it turns out that can accelerate cancers, because cancers, when they first seed in our body, they have to live on a low oxygen setting. So they actually love sugar as their substrate. So some studies show that if you eat sugar, these cancer cells actually do very well, and they grow more, especially like breast and colon and pancreatic cancer. So it's having a bad effect on cancer, and it's affecting other diseases as well, increasing the risk for diabetes and obesity. So this was kind of the big story, Mike. We kind of found that there was this pathway, and then we went on and figured out how it worked. And another thing then came a terrible discovery for many of us, and that was that it isn't just the fructose we eat. So fructose is in like soft drinks and pastries and fruit juice. It turns out the fructose in natural fruits is a completely different story, because they have a lot of good things that kind of counter it. So if you just eat a few fruit, you're okay. But if you're eating a ton of fruit, like the animals in the wild, just eat fruit after fruit, you're going to get fat from fruit. But generally speaking, fruit, it has a lot of good things, and we only eat small amounts. But so that we were thinking that the fructose was coming from the diet, and all of our studies did that. And then I was being interviewed, and I was talking to people, and it was clear to me that there was something more than sugar driving obesity. And I found that things like potatoes and French fries don't have much sugar in it, but you and I both know French fries aren't good for you.
Right.
And it turned out that the body can also make fructose. There's only one way, but it can make fructose from glucose. And when we discovered that this was happening, it was already known, so we didn't discover that, but what we found was that certain foods actually trigger the production of fructose. And then we kind of had this discovery that it looks like this is how high glycemic carbs, like bread, rice, potatoes, chips, cereal, that's how they cause obesity. Because if we feed it to animals and we block the fructose, the production of fructose, they don't get fat. And likewise, we found that salt does it. And you go, oh my gosh, salt? Doesn't even have calories. Well, salt activates the enzymes that produce fructose. But in order to produce fructose, you have to have glucose present. So usually the salt, it really works well when it's added to like a potato. So the potato provides the glucose, and then the salt helps turn that glucose into fructose. So it's like like if you're on a low carb diet and you're eating salt, it won't have the same effect as if you're on a high carb diet with salt. So there's a salt carb interaction, right? And so we found that certain foods, we even found that alcohol gets converted to fructose in the body. The alcohol itself doesn't get converted. The alcohol activates an enzyme that converts glucose in the body to fructose.
Right.
So the alcohol, it triggers the conversion.
Yeah.
So so you can imagine, if you can stimulate, alcohol does that. So then alcohol plus sugar, for example, that has glucose and fructose in it is much worse than alcohol alone. So, when we mix our drinks with rum and Coke, we're potentiating the way it works.
Yeah.
And then more recently, we discovered that so the way the fructose works is largely through this substance called uric acid, which I mentioned in the beginning
Yeah.
of my talk, and so the fructose makes uric acid, and then the uric acid is actually playing a role in it. And there are even certain foods that can raise uric acid really severely, and they also activate this pathway. So beer has alcohol, which does it, but it has brewer's yeast,
Mm.
which produces uric acid, and that really triggers it. And that's why there's the beer belly, and that's why beer in particular causes high blood pressure and increases in lipids or triglycerides. And so anyway, so the story of the book is this kind of the discovery process, how we went through this and discovered that sugar was working independently of calories and how does it work. And then we found that it was creating this survival switch, and we found that animals could produce it, could activate this switch. And then we figured out how the switch worked, and then how it relates to diseases today and so forth. And so it's and how we became sensitive to sugar. So the bottom line is it probably is a pretty important pathway in what's driving a lot of our diseases today.
Yeah.
And and one of the great things is we discovered along the way different ways to block it, and things that we weren't really thinking about. I mean, like reducing salt intake, or drinking more water, which blocks some of the effects of salt and so forth, and
Mm.
things like this. And so I have some kind of little pearls and clinical pearls, and some of these we have taken to the clinic, and so that's sort of what the story is about. There's a lot more in there too, of course, but
Oh, yeah.
story.
So fascinating, man. It's just
Yeah.
so fascinating. I mean, I'm gonna I'm gonna ask kind of a lay person's view of a lay anthropologist, put it that way. So, fruit was only ripe and available a certain percentage of the year, right? I mean, there was back in the day as we evolved, and getting fructose, unless you were willing to get stung by a bee, and getting fruit was kind of a rare occurrence during the year, right? And
Well, that's what we commonly think. But let me tell you the story behind this, and I'll
yeah,
talk about this a little bit more.
okay,
So, what oftentimes we talk about our ancestors as being hunter-gatherers
right,
and being hunters and hunting meat, and there's a lot of talk about that, and that's definitely the way it was, beginning about maybe a million years ago. But our ancestors before that were actually initially were vegetarian, or only partly omnivorous. They were mainly fruit eaters. So when the original primates were developing and evolving, the earliest ones go all the way back to the time of the dinosaurs, actually.
hmm,
But the first apes, which were ancestral apes, so they're not like modern apes, but these were the ancestors of the regular apes, and they were also ancestors of humans. They were living around 20 million years ago, and they lived in trees and they were eating fruit all year round. Now, back then it was more of a tropical environment, so there were a lot of fruits all year round, and it made up the majority of their diet. And so they were eating mainly fructose, and was the main food in fruit. So they were
okay,
really learning how to use fructose to their advantage.
hmm,
And as it around around 17 million years ago, there was a change in climate, and climate change is such a big deal today. But back then it was global cooling. It's really interesting. So we were going to talk, and I've ended up doing a fair amount of research on climate change and health. But this
hmm,
was kind of going the other way, global cooling. And what happened was the animals that were living the farthest north, they started having, just as you say, the fruit became less available during the cooler months.
hmm,
And so during those cooler months, originally the favorite fruit of all primates, like the chimpanzee and so forth, is the fig. and the fig is really rich in sugar. It's much richer than other fruit.
Yeah.
It's like concentrated sugar.
Right.
And, and the fig is really a cool fruit because the tree fruits all year round. And it does it sort of haphazardly, and it does it because of a special relationship with the fig wasp. There's a wasp that actually pollinates the fig, and it does so kind of at different times of the year.
Mm.
And so the fig, unlike many trees that will fruit at one time of the year, the fig can be fruiting all year round. And so it turned out that early primates just love the fig, and modern primates too. The fig is the favorite food of the chimpanzee,
Okay.
and this is why, because it's rich in sugar and it's often available all year round.
Mm.
And actually, in early, if you go back, I mean, there were like in the desert, people would used to take fig. They would make a fig brace, a necklace, sort of. And they would these fig wreaths, and they would wear them, when they were going across deserts and stuff, because it was provided this rich source of food and nutrients. But anyway, but figs are really important. And then what happened around 15 million years ago in Europe, where some of these ancestral apes were living, it got so cold the fig tree couldn't survive, or maybe the fig wasp couldn't survive. But once that happened, the fig was gone. And so what happened is those apes started starving in Europe, and you can find evidence for it. They would show signs of starvation in their teeth and their bones.
Mm.
And there's a famous anthropologist who's studying that, Peter Andrews. And I met up with him and talked to, and actually flew to London to meet with him, because it was during that time when there was starvation going on that there was a huge change in evolution. Evolution kind of sped up because as animals started starving, if you developed a mutation that provided a survival advantage, it often would take over all the ancestors. And so there was a mutation then that occurred in sugar metabolism. And basically, I mentioned that fructose was broken down to uric acid, and the uric acid is doing is driving some of these biologic effects. And there was a mutation that made the uric acid level much higher, so that when you ate a piece of fruit, instead of the uric acid going up a little bit, it went up a lot. And the higher it goes up, the more it would activate this process to be able to become insulin resistant, to increase the fat. So we actually realized that mutation in uric acid metabolism occurred during this period of starvation, and that it rescued some of these apes, who then went on to become eventually to become great apes, and also the ancestors of humans.
Mm-hmm.
And so that we are sensitive to sugar, more sensitive now, because we have this mutation that gives us a big boost. And the way we proved that was I know a scientist who was the first one to resurrect an extinct gene. The Jurassic Park. This is the guy, and he actually he's a brilliant man. He was nominated for the Nobel Prize. In fact, his name is Stephen Benner, and he's a friend of mine, and I'm grateful for knowing him because he's a very creative, really brilliant person. And he basically helped develop a method for identifying extinct genes and then resurrecting them. And working with Eric Gosher, who is one of these great scientists who trained with Stephen, trained under him, we were able to resurrect this extinct gene and show that when the mutation occurred, that this made us much more sensitive to sugar. So were able to show it in this kind of beautiful evolutionary path, evolutionary story. But anyway, so we became very sensitive to sugar. And initially, it didn't make us fat because we weren't really eating sugar. Table sugar wasn't around.
Right.
And so it just helped us keep our fat stores up better when there was no food around. And then around, around 400 BC, 500 BC, in the Ganges River Valley in India, these people started realizing that this reed that was growing there, that was called, sugar cane, that if you boiled the reed, you could get this syrup out of it, this sweet syrup that was as tasty as honey. And it was called sugar without the bees, or honey without the bees, rather.
Okay.
And these early people, when it was first discovered, it was kind of just kept in India. But by 500 AD, it was being brought into China, into Persia, into Egypt. And by 900 AD, it was brought into Europe and through Venice and initially it was really expensive. I mean, like a pound of sugar was like the cost of I forget what it was. It's like 30 pounds of cheese or some crazy thing. So
Right.
actually, that's not correct, but it's in my book. But it was incredibly expensive.
Right.
And so it was really afforded only by the wealthy and the royalty. And suddenly we see the appearance of obesity and gout and things like that among these people who were better, the kings and so forth. And then, people started growing sugar in the plantations in the Americas, and then also the sugar beet was discovered, and Napoleon kind of drove the sugar beet industry in Europe. And as sugar production increased, the price of sugar fell. And so in 1890 or 1900, sugar was still very expensive. And it was there was a study done in New York City, and the people who were developing obesity and diabetes were the wealthy. And back then, the African American had a very low frequency of diabetes, low frequency of obesity. And then, as sugar became more inexpensive, the general population could start eating it. And then we start seeing the appearance of heart disease, among the general population, and diabetes and obesity, and it correlates right with the sugar intake. And it goes up and up, and the things go up in parallel. And even diseases like Alzheimer's and cancers and all this, they're also going up. And it looks like it's this activation of this pathway that we've just, it's unfortunate. It was like an instinct. We wanted to learn, nature wanted us to be safe when there wasn't food around. So we became the experts. We're like the top of the food chain. We learned how to do this the best, how to become to store fat better than everybody else. And so we've got these really great genes. We're ready for it, and then we figured out how to produce sugar, not realizing that it was our problem. And so I think this is the big story. And then as we now we're figuring out that it's bad. But one of the problems, and which leads to your issue, is that we actually developed our taste buds for sweetness and for salt and for a uric acid, which is called the umami taste. We got those tastes so that we could help us identify these foods to put on fat. So that even it's at that level. So now, when we realize what's the problem, how can we stop it when we actually, our taste buds, our brains are wired. Nature wants us to be fat, right? We want to be able to identify foods that can increase our risk for obesity.
Right.
And so it makes it tricky. But the fantastic thing is, once you actually know how it works, you can intervene. And there are ways to turn off the switch, and there are foods that turn off the switch. And one of the incredible things is, once we kind of stumbled onto this and started looking at this, we realized that so many people's diets that are out there that are basically, we're all working together. I mean, a lot of this is coming from the other direction. These like low carb diets and low sugar and trying to control some of these foods that we know are bad and eat foods that are good. This is all predicted by our work. Precedes our work,
Yeah.
but is consistent with our work. And so, So as I was writing down, like the foods that are supposed to be good, and I look at how they play with the switch, and it's fantastic how they connect. So
Mm.
to me, that's actually some of the strongest evidence in support of this pathway. Is not the experiments we do in mice or the studies we've done in hibernating animals. It's the fact that there's so much brilliant science that's out there already and people figuring out great diets and approaches that already have done a lot of the clinical types of trials without fully understanding the story, the way that the switch works.
So fascinating. Unbelievable. I
Yeah,
hope everyone else enjoyed it as much as I did, but that story, I mean, I learned a whole lot, and because I've been studying it too, and you just turned a couple of light bulbs on for me. So, as I promised earlier, this is something that I got to get into because, in our work and the summit and education processes, I believe we need to know how we got into this mess so we can get out of it. It makes sense. And your story is just, amazing how but now we know, but now that we know, we have to change. And you have a quote in the book called Alcoholism is a Sugar Disorder, which is bold in and of itself. But here's the question. It's going to take a second to frame it, but if you're chewing on a cocoa leaf, you're going to get a little bit of a caffeine buzz, but you're not going to be cocained up and crack and everything with the powdered whatever. And so tell the folks the difference, between the fruit and everything and the powdered, reduced to a powder with no vitamins, minerals, nutrients, or anything. And the summit is loosely themed sugar in the brain. We've got Dr. Perlmutter, who wrote the forward to your book, I think. Yeah. And we've got Dr. Bresden. And so I'm trying in the sugar world to explain to people that the pathway that I believe you discovered that creates a behavioral change, the foraging, the hungry all the time, possibly could be affecting the brain in some way, and that you figured out ways to block it with drugs, and you're researching that, and you can talk as much as you're able to right now on that. But I want the folks to kind of realize that, the table sugar molecule, for some of them that don't know, is half glucose and half fructose. And people have been studying or worrying about the glucose, which is important, the diabetes and the insulin resistant, the metabolic syndrome and the weight gain. But the reason they cannot stop has to do with the fructose pathway that you've described the evolution of, and that the powdered stuff might be the high test, if you will, the cocaine of the coca leaf and the sugar of the sugar cane. Well, you're not going to chew on a sugar cane stalk. And so tell the folks how the reason people just cannot get off it. We talked about it before we came on. They're losing limbs, going blind, 200 and 300 pounds overweight. They can't stop. They're just, in my world, addicted to, I believe, the fructose, which is, affecting their dopamine, serotonin, norepinephrine. So again, long question, but I think you get it because I think your research is drilling right in on it. So help the folks there and let them understand that they need to, heal their brain or at least stop assaulting it with this stuff.
Yeah. Okay. Well, that's a wonderful introduction to this whole question of, what causes the craving of sugar.
Right.
And
you said it better than me. Good.
For the craving for sugar. So let's just begin, with a kind of, some of the things that we were looking at. And one of the things we realized was that that when the switch is turned on, that, we were trying to understand the mechanism of what drove the switch. And we found that it's a very unique thing. What happens is normally when you eat food, you're making calorie. It contains calories, and you use the food to make energy. And so we eat food to make energy, and we have good stores of our energy called ATP in our cells, and then the extra energy is put into fat, which is a form of stored energy. And what we've discovered about sugar and about fructose is it's different from other energy foods, any other foods, because it tends to set the energy in the cell lower. So instead of filling the cell up with and having creating energy, it actually tends to reduce the energy in the cell. And it does so, when it does so, it activates the survival pathway. And so it makes you want to search for food, and it creates kind of craving responses so that you want to go out there and look for things, and you're hungry and you're thirsty. And it actually appears to stimulate what the process is called the foraging response. So to forage, you have to, you're looking for food. You often have to go into areas that others have never, that you may not have been before. There could be predators, so you have to be looking around all the time. You have to be, never concentrate on anything for a long period of time. Deliberation is bad. You've got to look around. You've got to be prepared. You've got to be brave. You've got to be able to, it's sort of like a novelty seeking. You have to be able to go into areas you've never been, and you have to be able to make quick decisions, and you have to be impulsive. And so and the way it works, we even kind of figured out the way it works is remember I told you that a lot of the brain is insulin, does not require insulin.
Right.
So, but there are small areas of the brain that are insulin sensitive, that they do require insulin. And that's like with the sites, like the recent memory and the willpower and things like that. And when you become insulin resistant in the skeletal muscle, so that that the muscle's not getting enough glucose, the same thing happens when you eat sugar. The same thing happens to those insulin requiring, insulin dependent areas of the brain, like the recent memory and like the area for willpower. So you see the shift where you reduce your willpower, you can't remember as well, which actually gives you more, gives you the ability to be able to do things that you normally would not do. You're more willing to go out into a dangerous area because you don't want to remember everything that, that's dangerous out there. So it gives you
these are like back in the old days. This can be like doing dangerous acts now in real society, right? This is the same behavior. Yes. Okay, go ahead.
Yes, exactly. So what we realize is that if you put this system in overdrive for a long time, could it actually lead to behavioral disorders like ADHD,
right,
or attention deficit disorder, or bipolar disorder, or aggressiveness? And so in the book, I put forth all the evidence linking these pathways together. It's not proven, but there's a very good story that's that kind of links these behavioral disorders with sugar. There's been some, controversies on it. I discussed those controversies. I discussed that all. But we do think that that there's an actual biologic pathway for it. Mm-hmm. And so I think that, it's very likely playing a role. And epidemiologically, sugar intake correlates and so forth. You can show various aspects of this pathway. Foraging. So I believe that this is probably going on. Now, the craving is another thing. So originally we were wondering why do you love sugar? Is it because it tastes good? And so, and certainly the sweet taste stimulates dopamine in the brain, which is a pleasure response. Right. So, but there was a group that had knocked out the sweet receptor of the tongue and the buds, the tongue buds, taste buds, and by knocking out the sweet receptor in the taste buds, that meant those laboratory mice could not taste sweet. Okay. And when they did that, those mice lost all desire for artificial sugars, like Splenda and so forth. They got a little bit of dopamine. The normal mice, when they eat Splenda, they get a little bit of dopamine in their brains, suggesting there's a little bit of pleasure. But you knock out the sweet taste there's no pleasure with Splenda,
Mm.
But if you knock out the sweet taste, if they eating sugar, they still like sugar. So there's something about sugar that they
Listen to
like.
this, everyone. Listen, listen.
Yeah, even when they can't taste the sweet.
Right.
So we did a study with Miguel and Aspa, Tom Finger, Sue Kinnaman. Sue and Tom are like world-class taste experts, and they had a mouse that can't taste anything.
Right.
It's the taste blind mouse. It can't taste anything. And when
Right.
we gave it sugar, they still liked sugar, and
Mm.
they got fat from sugar. And actually,
Right.
they got fat with even less sugar than a normal mouse.
Right.
And so it turns out that what we now know is that the sweet taste does encourage more sugar. So when you eat something sweet, it encourages you to eat more. And that's probably why artificial sugars, they don't block craving. That's the problem with artificial sugars is they may actually encourage more craving, the craving
Mhm.
response. So although an artificial sugar doesn't is much safer than regular sugar in terms of risk for metabolic syndrome. It doesn't activate the switch, but it does keep you wanting to eat sweets. And so it doesn't solve the problem
Right.
of that. So anyway, then we knew that it was actually something else that was driving the craving. So when we blocked the switch, I talked about how it drops the energy.
Mhm.
Sugar drops the energy. Well, if we blocked the drop in energy, so that they could still metabolize the sugar, but they just didn't get that drop in energy, then we could block the craving. So we realized that the craving is related to this shift in energy.
Okay.
And that when the energy goes down, it's like your body wants more, and craving is one of those responses. So now what we're trying to do is we're trying to make drugs that can block this craving response. And there is a rare genetic disease where it's really not a disease. It's good to have. It's called essential fructosuria, and what happens is when these people eat sugar, they don't get that drop in energy, and there's no one who's ever been reported to have obesity or type 2 diabetes.
What's it called
And
again?
essential fructosuria, essential like essential,
Yeah,
and
yeah.
fructosuria means because what happens is when they eat sugar, they don't metabolize all that fructose, so they spill some of it in their urine. And so they can eat cake and all those things, and they won't get fat from it. Now, interestingly, they don't love sugar, so they can eat all they want. And I think I'm actually doing I'm hoping to do a study with a geneticist who's taking care of some of these people, because my understanding from what I know about this disease from them is that they don't mind sugar at all, but they don't love sugar.
Hmm.
What I'm trying to find out right now actually is, do they like sugar? I believe they do like it, but they just don't love it, and they control how much they eat. The reason
Wow.
I say that is because my mice that have this genetic problem, they'll eat they seem to like a little bit of sugar, but they won't eat a large amount. They're completely protected.
Hmm.
Some like things like high fructose corn syrup, they drink it like water, but for some reason with sugar, I think they eat a little bit more than normal.
Right.
So anyway, so sugar, is addicting, and it's because of its effects. One of the things about sugar is the more you eat it, the more you can get trapped by it, because what happens is the sugar in an animal that's never seen sugar, they will not be able to absorb it or metabolize it as well as an animal that's eating sugar chronically. So the more sugar you eat, the easier it is to absorb the fructose, the more rapid you metabolize the fructose. You kind of become an expert at being able to metabolize the sugar and to absorb as much. And we did a study in children at the Children's Hospital. And nowadays, obesity is becoming a real problem in adolescents. And we had a group of children that were overweight, obese, and we had some that actually already had developed fatty liver, which is really scary because that can progress to cirrhosis.
Mm.
So we had some kids with biopsy-proven liver disease, and then we had normal, kind of normal weight children. And we gave them a dose of fructose and measured how well they absorbed it. And what we found was that the kids who were thin didn't only partially absorb the fructose, but the kids that were obese, they absorbed a lot more. And the
Wow.
kids that had the fatty liver absorbed almost all of it. So they, the same dose of sugar had a
Right.
different effect. One got a lot more calories. One absorbed a lot more than the other. And they also metabolized it faster. So the people who had the fatty liver, not only did they absorb it faster, but they broke it down faster. And now we know that it's the speed with which you break it down that relates to how much the drop in energy is that triggers the switch. So they were, think of the switch like a dimmer. They were flipping it on big time, and the kids that were overweight were flipping it on part-time and, just turning the light up a little bit. And the kids that were thin, they were only putting it up a little. But we know from our studies in animals that the more sugar you eat, you can convert, an animal from being a poor absorber to a high absorber if you just keep feeding it sugar. So
I used to call that a push alcoholic, to push somebody who can push it on and it just keeps getting worse.
Yeah.
In our world, we call it the progressive illness. It just keeps getting worse, and it will get worse.
Yeah, exactly.
Wow.
So that's, so that's the story about sugar. Recently, we've been doing some studies on alcohol.
Yeah.
And it turns out that alcohol is really exciting. When you drink alcohol, or when animals drink alcohol, it causes changes in the blood that lead to activation of this enzyme that makes fructose. So again, it's not the alcohol being converted to fructose, but it turns on this enzyme that converts glucose in the body to fructose. And we found this, but it was also described by a group of scientists from University of Kentucky, and they found evidence for it in humans. And another group in China also confirmed that this was going on. So when we drink alcohol, we're actually making fructose, and so it turns out that sugar is actually the number one cause of fatty liver, for non-alcoholic fatty liver.
Right.
This is fatty liver that everyone's getting. It's basically got two major causes: alcohol and sugar. These are like the two major causes.
Right.
And now we know that alcohol makes sugar, or makes fructose. And so when we started studying our animals and giving them alcohol, they would get fatty liver. And then if we blocked the fructose pathway, we could block the development of fatty liver from alcohol. And in fact, so all these people that are developing alcoholic liver disease, it's probably not just the alcohol that's doing it. It looks like it's the fructose.
Right.
And the group in China actually blocked the production of fructose in animals, and they found that they could block alcoholic liver disease. And we blocked the fructose itself and found we could block alcoholic liver disease. And so it's becoming a very exciting area for the National Institute of Health. They funded us to do research on this. And we also found, to our amazement, that we could reduce alcohol intake in alcoholic animals by blocking fructose metabolism. And so I have to confess that I've started a little company, and we're trying to make inhibitors of fructose as a way to help control alcoholism, because that would be a spectacular,
Wow.
benefit.
That's what I was hoping for you would announce and bring out on this summit. So would the same drug affect people with sugar they block, if you could block the pathway for them?
Yes, yes, it should. It depends a little bit on where the drug is concentrating, but I think it's going to work on both.
Right.
Yeah.
Wow.
Yeah.
I'm not
So-
sure. I know I could talk to you for another 2 hours or longer, but we were already probably one of the longest interviews ever. So tell the folks what else. I can't imagine that you may have dropped the bombshell of the century right there, because that would change the world. What else is going on in your world, and what do you see coming up?
Well, we're still, we've got our hands full with trying to do all these different things, making drugs, for example, to block this pathway, but we're also really interested in the science. I'm also looking at the interface of climate change with this pathway and trying to understand these disease processes. We think that this could be important in Alzheimer's, for example, is another disease that could be where this pathway is likely involved. And so we're, you can come back. We can have another interview, maybe 6 months.
I'd like that. We'll do it to promote the book when it comes out. How's that?
That sounds wonderful.
So
thank you, Mike.
Yeah, no, thank you. Real quick though, the brain is. I'm going to talk to Dr. Bresden at 8:00 tonight. So the brain is deeply, and dopamine is deeply involved in this sugar pathway, right?
Right, absolutely.
It's not just the physical body. So this is so exciting to me after seeing that. Anyway, I'm just amazed. I'm in shock again. So tell the folks where they can reach online, where the book is, gang. It's Nature Wants Us to Be Fat. It's on pre-order right now at Amazon. An amazing book, goes heavily into detail about what Dr. Johnson has just spoken about. And so if you're interested, please support him and get those pre-sales up there. Anything else? Do you have a website or anything?
Yeah, I do. It's called drrichardjohnson.com. And
Okay.
I encourage you to go there. I've got little stories in there. So it'd be great to have you come there.
Yeah.
And yes, I'm looking forward to hearing from readers and learning from you as much as I can myself. So that will be great.
Cool. No, exactly. That's the feedback is amazing, very valuable.
Man.
Well, thank you again, sir. I really appreciate it. And we will talk again. I hold me to it. When the book comes out, I want to do something and blast it out to the group. So, okay.
Thank you.
All right. Take care.
Bye-bye.
We hope you are enjoying all the speakers. We know that 5 or 6 speakers a day can be overwhelming. To be able to listen to all the speakers over and over again, and to grab thousands of dollars worth of speaker bonuses, including detox courses, menus, recipes, and a whole lot more, make sure you click on the speakers package link and guarantee your success.